Hi everyone, welcome back to my new math tutorial video. Today I'm going to cover factoring quadratic equations with leading coefficient of 1. As we all know that the general form of a quadratic equation is ax squared plus bx plus c equals 0, where a cannot be 0 and those two coefficients b and c are constant. And today's focus is when a equals 1. And here's the general form for that. Next, I'm going to introduce 3 different cases of quadratic equations when the leading coefficient is 1. And after that, we're going to do the factoring, and then we are going to solve some problems for each case. Before we move on, I'm going to make a simple assumption, which is all the equations today have solutions, and all the solutions are integers. Just make it simple and easier for you to understand this concept, the factoring thing. There we go. So now we have first case. So when b equals 0, we have x squared plus 0x plus c equals 0. And simplify it, we get x squared plus c equals 0 as our general form for the first case. Here I have to point out that c has to be negative or 0 in order for this equation to be valid, since x squared is always positive or equal to 0. And how do we factor this equation? So let's do a recall here. We know x squared minus b squared is equal to a plus b times a minus b. So we can apply that to the equations here, since c is negative or 0. So now we have x plus square root of absolute value of c times x minus square root of absolute value of c equals 0. So now we have two solutions. One is negative square root of absolute value of c, and the other one is positive. And let's do an example. And here is my example, x squared minus 9 equals 0. And here is the equation after factoring. So now we have c equals negative 9. All we need to do is plug that into this equation. We have x plus square root of 9. Since the absolute value of negative 9 is 9. And then we have x minus square root of 9 equals 0. Now we have 3 and negative 3 here. So our first solution would be negative 3, and our second solution would be positive 3. So the first case is very simple. And here's the second case. So when c equals 0, we have x squared plus bx plus 0 equals 0. X squared plus bx equals 0. So we see x is the common factor of both two terms here. So we can factor it out. So we have x times x plus b equals 0. So our first solution is going to be 0, and the other one is negative b. Here's an example. So I have x squared plus 7x plus 0 equals 0. And that's the equation after factoring. So we know here we have a b equals 7, and then we can plug this in. We have x times x plus 7 equals 0. So our first solution would be 0, and the second solution would be a -7. It's very straightforward. Here comes the third case, and this is the most complicated one. Since we don't have any 0 here for those two coefficients, suppose we have b and c are not equal to 0. And we would just have the general form for that. So now, think about it. If this equation can be factored, then we always can have an equation after factoring, which is x plus a times x plus b. So now we're going to do the reverse process. So we expand that into 4 terms here by using FOIL method, right? Find all the first terms, inner terms, outer terms, and last terms here, right? And that would simplify it. We get x squared plus a plus b times x plus a times b equals 0. And those two equations, they should match, right? Because we're doing the reverse process. So now we take those two equations out, and we see that the highlighted part, so all those coefficients, should be equal, right? And we can compare those two equations and can set up the equal sign for those two coefficients, and that's what we get. So we have b equals a plus b and c equals a times b. And those two a and b, so they are capitalized. A and b has nothing to do with the small a and b, okay? Let's do an example. So now we have x squared plus 5x plus 6 equals 0. So here is the equations that we got from the previous slide. B equals a plus b and c equals a times b. So now, what is the b here? So we have b equals 5 and the c equals 6. So then we have a 5 equals a plus the uppercase b, and then have 6 is equal to a times b. So now let's find the factors of 6. So we have 1 times 6 and 2 times 3. So I have those two pairs. So which one can satisfy the first equation? It's the second pair, right? So now we have a equals 2 and b equals 3. Okay, so then we plug those into that general form. We have x plus 2 and x plus 3. So now the first solution would be -2, and the second solution would be -3. Let's do a second example. So now we have a b equals -5 and c equals 6. So we can set up the same equation here, and 6 equals ab. And still, we check all the factors of 6. So 1, 6, 2, 3. So since here is a negative, so both of them cannot satisfy the first equation. So we may think about the negative factors. So we have 2 more here. -1, 6, -2, and -3. So which one can give you a -5? It's going to be -2 and -3. So A is equal to -2 and B is equal to -3. Again, we plug those into our general form. So we have x minus 2 times x minus 3 equals 0. So here's our first solution, x equals 2, and our second solution, x equals 3. And here's our third example. I keep changing the sign of two coefficients. So now I have b equals -5, c equals -6. So now we do the same thing. So -5 equals a plus b, -6 equals a times b. So now we have 4 pairs, -1, 6, -2, 3, or 1, -6, 2, -3 for the factor of -6. So then which one can give me the -5? We do -1 plus 6, that's 5, 1 plus -6, that's -5. So it's going to be this pair, 1, -6. So we have A equals 1 and B equals -6. So same thing happened here, plug this in. So we have x plus 1 times x minus 6. So our first solution would be -1 and our second solution would be -6. So now is a summary. So here all solutions are integers. So our first case is that is when b equals 0, and the second case is when c equals 0, and the last case is both of them not equal to 0. Try your best to memorize them, to understand them. And that's pretty much for today, and I will see you in the next video.